In this lesson, we are going to talk about fitting a line to data and then using our knowledge of writing equations to write an equation for the line. Here's what I mean. Let's focus on what we've learned in the past. To write an equation, we need two things. We need to know slope and we need to know the y-intercept. That hasn't changed. Okay? And we've done this in a few ways. In one of the lessons, we were just given m equals something and b equals something. We were given the slope and the y-intercept, and using our slope-intercept form, y equals mx plus b, we just plugged in our m and b. And then we took a step back and it said, okay, we're not going to give you b, we're going to give you a point. And then we were able to use again our slope-intercept form, plug in our m, plug in our x, plug in our y, and solve for b, and then write the equation. And then they took us back a step further, and instead of giving us 1 point, they gave us 2 points. Well, we could use those 2 points in our slope formula to find the slope. And then again, once we have our slope and a point, we can plug it in to solve for b. We're still going to be using all of this, but sometimes we need to draw the line first. Here's what I mean. This is a best fitting line, and just an FYI for you, sometimes you'll hear it referred to as line of best fit. Means the same thing. Okay, but either, best fitting line or line of best fit. It says you are studying the way a tadpole turns into a frog. You collect data to make a table that shows the ages and the lengths of the tails of 8 tadpoles. Draw a line that corresponds closely to the data and then write an equation of your line. Okay, so what we're saying here is that if we have a 5-day-old tadpole, his length is 14 millimeters. Again, there's a relationship. We can write an ordered pair if there's a relationship. If we have a 2-day-old tadpole, in this case, their length is 15 millimeters. A 9-day-old, we have 3 millimeters. A 7-day-old, you get the picture that these are all ordered pairs. So what we can do now is we can plot these ordered pairs, this relationship, on a graph. Let's start with that. So our first point was 5/14th, and so if you look at my graph here, I'm going to put the ages, because that's our independent variable, on our x-axis, and I'm going to put the length on our y-axis. And I'm just looking at all the numbers we had here, they don't look too bad, so I'm going to go by twos. 2, 4, 6, 8, 10, 12, 14, 16, don't know why I wrote 14 there, sorry, 16, and 18, 20, excuse me, and I'll go by twos going up here too, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, okay, and then you just go ahead and you plot the points. 5, 14, 5, here's 6, this will be 5, and then I go up to 14, which will be right here. Our next point is 2, 15. Here's 2. Here's 15. 9, 3. Let's go over here to 9 to 3. Okay. We also have 7, 8. 7 would be right here. 8 is right here. We have the point 12, 1. We're to 12 days, and 1 would be halfway in between. 10, 3. It's 10 and 3. We already have that point because I messed up. We have 9, 3 and 10, 3. I'm sorry. 9, 3 should be right here. And then this is 10, 3. I apologize. I put the 9, 3 where the 10, 3 should be. So, but we do have both of them now. 9, 3 and 10, 3. 9, 3, 10, 3. We also need 3, 12. So here's 2, 3, and 12 will be right here. And 6, 9. 4, 6, and 9 will be right here. Okay. Now, what this graph shows is that the ages of our tadpoles, as it's increasing, what's happening to our length? Well, we can kind of see the dots. Although it doesn't lie in a perfect line, we can see that the trend is that the dots are decreasing. Okay? If I wanted to predict something, if I wanted to say, okay, here's 4. I didn't have any tadpoles that are 4 days old, but I want to make a prediction on what the length would be. What I can do is draw a line in. To write an equation for a line, yeah, we need to find the slope and y-intercept, but first we have to have a line to write the equation about. So this is what a line of best fit means. You are going to draw a line that best represents your data points. So everyone's lines are going to look a little bit different. Okay? So I'm going to draw my line in like that. Your goal is to just kind of work it so it best describes all the points. It's okay that they don't all lie in the line, and it's going to be okay that if your lines lie different or look a little bit different. Okay? But you want to draw a line where you can get as many points as close to it as possible. So if we look at this, this blue line here is my line of best fit. Again, excuse me. We're going to be able to draw an equation now that correlates to this line. But remember, we need to be able to find the slope and the y-intercept before we can do that. Well, to find slope, we need at least to find 2 points. You need to pick 2 points on here. They can be actual points, or they don't have to be points. Like maybe I want to pick this one right here. Okay, this is the point 8, 6. None of my data points were 8, 6, but it's okay because it's on my line. Okay, then maybe pick another point. I am going to, I'll just take maybe this point. Oh, it doesn't really go through there. You want to pick a point on your line. So maybe I'll move my line a little bit. But I'm going to pick this point right here. Okay. Again, that was the point, and this is one of my data points. 2, 15. You don't have to pick these 2 points. You could pick any 2 points that lie in your line, even if they're not one of your original data points. So now let's take these 2 points, 2, 15 and 8, 6. And when we have 2 points, we can write an equation. Use your slope formula and use your y-intercept form. Okay, again, any 2 points on the line. So to find the slope, I take the difference in my y's over the difference in my x's. So I can say 6 minus 15 over 8 minus 2. 6 minus 15 is going to be a negative 9. 8 minus 2 is going to be 6. And if you reduce that, you get a negative 3 over 2. Now, to find my y-intercept, you take your slope and one of the points. Doesn't matter which one. Using slope intercept form, plug in what you know. My y is 15. My m is a negative 3 over 2. My x is 2. And I don't know what my y-intercept is. I can figure it out. If I solve this equation, my 2's cancel, and I'm left with just negative 3 plus b. Add 3 to both sides. You get 18 equals b. So now I have my slope of a negative 3 over 2. I have my y-intercept of 18. Can I write an equation in slope-intercept form? Absolutely. Y equals negative 3 over 2 times x plus 18. This work is everything you've been working on so far this chapter. The new thing about this lesson is that you actually have to draw the line to come up with this point. Now what we can do now is we can test it. Let's try. Let's try our input value here of 4. What is y going to be equal to when I input a 4? Oops. If I go negative 3 times 4 and then divide that by 2, I get a negative 6 plus 18. So that means my y is going to be equal to 12. So I inputted a 4 and got out a 12. Let's see how that compares in our line. Look at 4, 12. It actually falls exactly on my line. But what you're going to find is sometimes you're going to be off a little bit, but it's okay because you're using that equation to be able to make predictions for the information you don't know. Just to kind of sum things up, we're still going to be writing an equation for a line, so we're going to need a slope and a y-intercept. But what you're going to have to do first is you're going to have to draw a best fitting line, a line that best represents your data points before you can write your final equation.